Hi everyone, this is another centripetal force problem, and here we go. This is about a car on a flat curve, meaning a curve that does not have a bank on it. Exit ramps always have a posted exit speed. An engineer is trying to calculate the maximum exiting speed for a particular ramp with a radius of 51.0 meters. What is the maximum speed when the pavement is dry and the coefficient of friction between the tires and the road is 0.950? And what is the maximum speed on a wet, snowy day when the coefficient of static friction drops to 1.00? All right, here goes nothing. If I've got a car that is on an exit ramp like this, you have to have a force that is holding it towards the center of the circle, and that's going to be my centripetal force. In this case, what is causing the centripetal force? That is friction. Now, in order to do this problem, I am going to have to sum the forces on my vehicle. So here is going to be like a little sideways view of my car. Here's my car, taillights, back window. Gravity is going to pull down on the car. Normal force is up. And towards the center of the circle, the centripetal force is caused by the friction force. So those are the sum of the forces that I have. The radius I know is 51 meters, and I have two coefficients of friction, dry coefficient of friction of 0.95 and a wet coefficient of friction that drops 2.1. As we have done many times before, we're going to sum the forces horizontally and sum the forces vertically. So if I sum the forces horizontally, the car is in a curve, and so that means it is accelerating, and the sum of the forces horizontally is going to make my mass centripetally accelerate. The sum of the forces vertical are going to equal 0 because of the fact that the car is not falling through the ground or accelerating upward above it. So let's make our equations. Horizontally, the only force that's causing the centripetal acceleration is friction. So friction force is going to make my mass centripetally accelerate. Vertically, normal force is going to equal force of gravity. Now I can replace friction force with mu times normal force, but I do not know normal force, so let's go over to the vertical side, and I'll find that normal force, I can replace gravity with mass times the acceleration of gravity. So I'm going to replace mass and acceleration of gravity for my normal force. Mu, mass, acceleration of gravity, is mass times centripetal acceleration. The mass is not given primarily because of the fact that coefficient of friction is independent of the weight of the object. Now I want to know something about speed. So let's kind of clean this up. Mu, acceleration of gravity, is going to equal centripetal acceleration. I need something for speed. Mu I know, gravity I know. What am I going to do with centripetal acceleration? Well, I have two equations for that. V squared over r, or 4 pi squared r t squared. If I want to know exit ramp speed, which version of centripetal acceleration am I going to use? This one or that one? Okay, let's use the one with velocity in it. So I'm going to replace centripetal acceleration with that, and I'm going to end up with mu, acceleration of gravity, v squared over r, and I'm looking for velocity. So velocity is going to be mu, acceleration of gravity, times r, multiply both sides by r, and to get rid of the square, I'm going to square root that. Now I only have to do this equation. I've done all the algebra, all the physics, now I just have to do some calculator crunching. So velocity on dry pavement is going to be, coefficient of friction is 0.95, acceleration of gravity is 9.8, and my radius is 51 meters, and everything has 3 sig digits. On dry pavement, I end up with 21.8 meters per second dry. Okay, what about on a snowy, wet day? Then what's the velocity going to be? So, hello, I'm having a challenge finding the right spot on my page. Oh, let's try this. Okay, velocity wet is going to be 0.100, 9.8, times my radius of my curve, 51 meters. And the velocity on a wet day is down to 7.07 meters per second. So your driver's ed instructor was right. Slow down when it gets slippery and wet. All right, see you later. Bye.